That would be like the cosmic microwave background measurement. And then you used a model of how children grow to predict how tall they ought to end up at adulthood, and that would give you a height. And then you would actually measure when they grew up how tall they were. And so that's the comparison we're making, the present state of the measurement versus what is a very precise measurement in a younger universe, and then a model like the growth curve of a child to predict how tall they will be. Except unlike a child, we've seen many children grow. We have a very good understanding of that growth curve. We've only ever seen one universe, and it's full of stuff whose nature we don't deeply understand. And so it's not crazy to think that we might be missing something in that understanding. In order to predict and really extrapolate the state of the universe from the beginning to the present day, we have to understand components of the universe, particularly two components whose nature is not well understood but make up 96% of the universe, and that's dark matter and dark energy. Dark energy makes up about 70%, and dark matter probably makes up about 25 to 27%. And we don't really understand at a detailed level what these are exactly. We don't understand their microphysics. So in order to make these predictions, we assume that they are their most vanilla or plainest possible forms. We see this tension then, and so one possibility, not the only possibility, is that they are more complicated, that there's a more complex story, or some other aspect even that we've been missing about the universe. The Hubble Space Telescope has more or less been working on measuring the Hubble constant for its entire lifetime, about 30 years. So the original goal when it was launched was to measure it to 10% uncertainty, and I think that was successfully accomplished in the early 2000s. We're now on sort of what I would say is the second generation of measurements of the Hubble constant that are targeting closer to percent level precision, and I think Hubble, especially with its new instruments, has absolutely come through with the capabilities needed. Hubble really has delivered the quality and caliber of data that's necessary to make these measurements.